Good morning, ladies and gentlemen. Today we're going to continue our work with inequalities. What we've worked over the past few days is looking at inequalities as lines and graphing them. And then we learned solutions yesterday, where we graphed two lines on the same coordinate grid, and their answer was where the overlap was double shaded. Today we're moving on and combining the rest of this chapter together. So we're going to be graphing a line inequality and a parabola inequality using either the generic rectangle diamond problem or using the quadratic formula. And then the answer once again will be the double shaded areas. So we're going to go ahead and jump in and look at this first example. We're going to start with the line, which is y is less than negative 2/3 x plus 2. And we're going to graph that the same way that we did yesterday and the day before. So we're going to go ahead and take a look and plot that y-intercept. So we're going to go ahead and plot a dot on the y-axis at 2. Now we're going to take a closer look at the slope. We know our slope is rise over run, and it's negative 2/3. That means that from the y-intercept of 2, we're going to go down 2 and 3 to the right. And that's where that is going to end up. We then take a closer look at our inequality. We see that it is a less than inequality, and we know that a less than or a greater than means a dashed line. So we're going to create a dashed line between those 2 points. And the less than, of course, means below. So we're going to shade below the line that is dashed. Now, a little bit more work for our second one. We're back into the beginning of the chapter mode in chapter 8, where we're going to go ahead and we're going to find the roots of our parabola. We know it's a parabola because it's an x squared. So y is less than or equal to x squared plus 2x minus 3. So as always, our first step is to go ahead and pull out that a, b, and c. A is the number in front of the x squared, so it's that invisible 1. Our b is a number in front of the x, which is 2. And c is our constant, which is negative 3. I'm going to go ahead and use a generic rectangle diamond. You can use the quadratic formula if you wish. We know the top of our diamond problem is a times c. So 1 times negative 3 is negative 3. And we know b bottom, b bottom, b bottom, b bottom. So 2 is going to go in the bottom of our generic rectangle. We're now looking for two numbers that are going to multiply together to be negative 3 and add to be 2. There's only one way to multiply to get 3, and that's 1 times 3. We know it's going to be a negative 1 and a positive 3 because we add them together for the bottom, and 3 minus 1 gives us that positive 2 on the bottom. Now we're going to go ahead and transfer that into our generic rectangle. We start with our x squared from our original equation in the bottom left, and our c goes into our upper right-hand corner, so that negative 3. We're now transferring the right and left from our diamond problem, adding an x into our remaining squares. So we have a negative x and a 3x. We're now analyzing and taking those outsides out to find our product form. So the only way to get x squared is x times x. We know that x times negative 1 would give us that negative x, and x times 3 would give us 3x. We're going to go ahead and write that in product form. So we have x minus 1 times x plus 3. Now we're going to go ahead and move from product form using the zero product property in order to find our roots for our parabola. And remember, our roots are the same thing as our solutions and our zeros, and it's where it crosses the x-axis. So we're going to set each set of parentheses equal to 0 and solve. So we have an x of 1 and an x of negative 3. So we're going to go ahead and plot those on our coordinate grid. We have a 1 and a negative 3. Our next step is to find the vertex. We know there's multiple ways of doing that. We can add these two numbers together and divide by 2. That would give us a negative 1. Or we can use the formula negative b over 2a in order to find the x value of our vertex. So I'm going to go ahead and do that because it's new and we're practicing it. So we have negative 2 over 2 times 1, which is negative 2 divided by 2. So we have an x value of negative 1. And when we look at our graph, we can see that that's going to be right in between. Now we know the x value, we just need to find out exactly where that vertex is going to be. So we're going to take that negative 1 and we're going to plug that back into our original equation, and we're going to solve for y. So we plug that negative 1 in multiple spots, remembering your parentheses. Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 3. So we have a y value of negative 4. We're going to have that complete the ordered pair, negative 1, negative 4, and we're going to plot that on our on our coordinate grid. We look now specifically at our inequality. It's less than or equal to. That means it's going to be a solid parabola. And it says less than. Now, this one's a little bit harder, so you really have to plug in a point. As you know, I always love to plug in the point 0, 0 to see if it makes a true statement or a false statement. If it's a true statement, then we need to shade there. If it's a false statement, we need to shade on the outside. So when I plug in 0, 0, I get 0 is less than -3. Is 0 less than -3? No, it's not. So we know we need to go ahead and plug in the outside of that coordinate grid. And there you have it, ladies and gentlemen. The double part shaded, which is here and all the way over to here, is our solution. Remember, anything that is on the dashed line is not a part of our answer, and anything that is on the solid line does make a true statement and is a part of our answer. We have a couple problems that you guys are going to be working through today on your Desmos assignment. And then you're going to go ahead and do old school explicit equations for sequences, which is just those adding, subtracting sequences that we're putting in the form y equals mx plus b. We've been working a lot with lines this chapter, so I'm sure you guys will do great on that. Remember, if you're struggling with con, go ahead and watch those videos and use those hints, and feel free to email me and I'll get back to you with some additional help. Thank you guys so much and have a wonderful weekend.